Welcome back, everybody. This is the Multi-Cloud Network Architecture Series, Episode 8. And in this episode, Dana Systems, my company, got hacked in AWS. I think all this attention that we were getting on the market, being in the news, our application doing so well, the acquisitions we've made, it's made us a target. So now we need to quickly deploy a next generation firewall solution. And we need to do this in the most optimal way. No old-fashioned deployment models. And I'll talk to you about those models in a moment. Here are the requirements. Number one, east-west, west-east traffic needs to be inspected. So that's VPC to VPC traffic, VPC to VNet traffic, VPC to GCP VPC traffic, whatever it is, all that needs to be inspected. Number two, any egress to the internet, to the public world, needs to be inspected. In a future video, we'll also do ingress inspection, but it makes this video too long to do that as well. So we'll just do egress for today. Number three, we need to ensure that this is high throughput. I'm talking about 50 gig plus throughput. But we need to do this with the least complexity possible. We need to also make sure that the source IPs are being preserved for the end-to-end traffic flow. Why? Well, that's the whole point of this, right? We want to make sure we can see who's talking to who and nothing is being hidden for our security correlation. Number five, each AWS region needs to have its own firewall cluster. We're going to do that so that we have optimal egress, closest egress, as well as the closest point of firewalling in each region. Now, just for the heck of it, I'm going to deploy a Fortinet cluster in AWS West and a checkpoint cluster in AWS East. Maybe there's two different groups within the org that want to use both solutions. I just really want to show you how easy it is to deploy really any next generation firewall. We also support Palo Alto, and we're going to be supporting others in the near future. Lastly, we need to make sure this is repeatable across all clouds. Let's get to it. Let's level set by looking at the topology together. We're going to be focusing on two transit networks, the transit network in US West and the transit network in US East, both in AWS. These are going to be our FireNets, which is just a firewall VPC that we configure, we build, we configure the subnets for, we configure the routing in, all that stuff. We're going to insert Fortinets into the West transit and checkpoints in the East transit. We're also going to have secure workload VPCs connected to each transit in each region, and the transits, of course, will be paired together with high performance encryption tunnels. Each transit will have access to the internet, so you have the local egress, and then all these transits will be meshed together so they can have connectivity to Azure and GCP. Now, I've already taken the liberty to build out the bare bones of this already. I'm talking about building out the VPCs, configuring the peering relationships, configuring the workloads and the hosts and all that stuff. I really don't waste time doing that. You've seen me do before. It's super easy with Aviatrix. We have tools built into the UI to build out these VPCs and the connectivities all automated for you. It really only took me about, 10 minutes at most to build out what you see here on the screen. What we're going to focus on is the instantiation and the configuration of the firewall networking and then showing you how it works. So from the Aviatrix MCNA perspective, what layer of cloud networking do you think we're working with today? If you said the transit layer, you're absolutely right. That is where your next generation firewalls sit. That's where the services get inserted dynamically, and that's what we're going to be messing with today. Remember earlier I mentioned that we have to deploy these firewalls in the most optimal way possible to get the best throughput and the best visibility, best performance through these firewalls. Well, there were old ways and suboptimal ways to deploy firewalls in the cloud that people have been using for quite some time now, and they're starting to run into all sorts of problems. At Aviatrix, we've solved all those problems. So let's first take a look at what those problems are. Number one, the traditional way of deploying a transit VPC with firewalls in them was to have an active standby setup, and then to connect those active standby firewalls via IPsec tunnels and BGP to the VGWs in the spoke VPCs. Why is this suboptimal? Well, then you're limited to 1.25 gig per tunnel. That's just how the IPsec encryption works when terminated on native cloud constructs. In addition, your firewalls are now stuck in active standby. You're not leveraging them to the best performance, and you're not making use of your licensing. It's complex to manage because you have all these IPsec and BGP tunnels that you need to manage and handle and configure and monitor. And then it's complex to troubleshoot, right? You have all these peerings and all these BGP connections and IPsec tunnels you have to just go and monitor, manage, and manually look into when it comes time to troubleshoot. Really not optimal. Even if you're using the AWS TGW for firewall insertion, it isn't optimal. You still have active standby in this architecture. You're stuck to 6 gig. And if you're doing equal cost multipath VPN tunnels to firewalls to make them active, well, then you have to enable source NAT because firewalls are stateful and you need to make sure that the traffic's symmetric. So then you lose visibility into the actual source IP. And you have all this additional complexity, right? You have the dealing with the IPsec to BGP, you're back down to 1.25 gig, you have the lack of visibility. It's just complex. This is really not how you should deploy firewalls in the cloud. Please don't do it this way. Let's now take a look at how we've solved this at Aviatrix. So we leverage our gateways as the first point of entry into the firewall network to handle all sorts of things. We'll handle the symmetric routing, we'll handle the active architecture, the hashing. We'll monitor the firewalls. We'll monitor the gateways. We will insert and remove the firewalls dynamically when needed. We'll deploy the firewalls for you. We'll monitor the health of the firewalls. And we'll support integration with the management tools of your next generation firewall platform. Lastly, we'll handle the routing end to end for you. We'll insert the firewalls in the path of traffic depending on the policy that you've created in the Aviatrix controller. Here's a deeper look at how it works. We have a region, we have a transit VPC where we place the firewalls, we front end them with our gateways, and then we have gateways in your different VPCs. Those all connect to each other and traffic flows depending on the policy. Here's an even deeper look. You can see that we can actually scale out up to 10 firewalls per availability zone. That means we can get upwards of 70 gigabits per second in and out of these firewall VPCs. Pretty incredible. Let's get configuring. So let's get started. The first thing we do under Transit Network section, under Transit FireNet, we're going to enable the Transit FireNet function on the transit VPCs that I created, okay? So the first one is the West FireNet Fortinet Gateway environment. So hit enable, and if I go back to my Lucidchart while it's enabling, I'm enabling that in here in this environment. Now the firewalls haven't been spun up yet. I'm just enabling FireNet functionality on the VPC and on the gateways themselves. Bam, there we go. It's all done. Let's go do the same thing for the East FireNet checkpoint gateway environment. That's this one over here where my checkpoints are going to go. Bam, that's done as well. If we scroll down, you can see we can now select the different gateways and enable spokes attached to those gateways to be inspected by the FireNet. We'll come back at a later time to manage the FireNet policy. For now, let's just deploy the firewalls. So we go down to step 3 and click go, and it'll open up another window for us and take us to the correct spot in the workflow to deploy those firewalls. So let's start with the Fortinet FireNet environment in the West region. It's already selected as my VPC ID. The gateway is already selected for me. You don't have to mess with that. Let's just give it a name. Let's call it 41. All right. And then let's select Fortinet Next Generation Firewall. Leave the image alone, the version alone. Let's raise this to a higher image size. Let's do like C5, I don't know, 2x large sounds fine. Egress interface subnet, let's select one of those. Now we've already labeled these. Actually, Aviatrix has labeled these for us, these subnets. It built the subnets and also labeled them for us when I deployed it using the built-in VPC builder. So let's just select this one down here, the ingress egress 2A. That's because it's supposed to be an egress subnet. And everything else can be left default. You just got to click launch. Now you could use the advanced section here to specify an IAM role for it, and also you could bootstrap it by giving it an S3 bucket URL so that you can grab the bootstrap file and actually configure some of the firewall for you. But for now, we're just going to leave it default, hit launch, and get management access to the firewall and to configure it. So give it a little bit of time, and it will deploy that firewall for us. Well, that was fast. It deployed it for us pretty quickly. You can see here that it gives us the instance name, the instance ID, the vendor name, the VPC ID, the management UI URL, so we can click that and go directly to the management UI to start configuring that firewall. And also it configured the PEM for us, and you can download the PEM file from here if you want. But before we go and configure the firewall, I want to deploy a second one connected to the HA gateway. So we're going to call it 42. Oh, we already had 42 in there. We're going to select the Fortinet. Again, same situation. I think last time, what did I do? 2x large, C5 2x large, yep. And in this case, we're going to select, let's do the alternate ingress egress 2B. All right, and just hit launch. All right, and Fortinet number 2 is done. Both of them are connected to the gateway. They're both up and running. We need to configure them, however, and so it gives us access via the management UI. Just click this link. It'll open up a new window. All right, it says, you know what? It's the first time you're logging in. The username is going to be admin, and the password is the instance ID. So we can go and grab the instance ID from the Aviatrix UI. Let's copy that. Admin. Pop that in there. Bam. Now it's asking me to change the password. So the old password was the instance ID. I'll put a new one in here. Hit OK. Log back in. All right, we're going to do this later. And there you go. You get access to the UI of that FortiGate firewall that we deployed. And now we have to go configure some of the basic things like IP addresses and some routing and some policy, just Fortinet specific stuff. Now, I'm not going to bore you guys by doing that in this video because you know what? It's not a part of the whole Aviatrix deployment process. You can just go to our docs site and we step you through it, right? You have guides, you have screenshots. It's so simple, really. So just go there and do that. So give me some time and I'll configure both firewalls and come right back. Now, just so you guys know, what happened in the background was that Aviatrix went and deployed the subnet, the routing table entries, the interfaces, the EIPs, the instances themselves, like everything for you just to give you this access, and then we can start rocking and rolling. All right, I'm done configuring both firewalls. You can see I have my interfaces configured under the routes, static routes. I have my static routes configured. All the RFC 1918 will hairpin in and out of LAN 2, so coming from the gateways, going back to the gateways, and then to go out to the internet, it'll go out the WAN interface. So I have a default route hitting the WAN interface. Now, if I go under policy objects, I have two simple policies in here just to show that traffic will hit the policies. One is to allow any LAN to LAN traffic, so it's any VPC to VPC that's being inspected, and then allow internet traffic, so anything coming from a VPC going out to the internet. Now, I could create some custom rules in here to block things, but I might do that later just to show it. But I just want to make sure that I'm getting some logs and stuff are hitting the firewalls once I allow inspection of those VPCs. I haven't done that yet. Remember, if I go back over here, under this section right here, I have to actually enable the inspection. Before I do that, I want to just run a couple tests of traffic within the VPC workload to show you that it's not hitting the firewall, and then I will enable it and then show you that it is hitting the firewall. Before we actually insert the firewalls into the path of traffic using service insertion, I'm going to test communication between the secure workload that I have running in the west to the secure workload I have running in the east. Now, I updated some of these IPs and made mistakes earlier. It's actually 10.160 and 10.161. Doesn't matter. So you're going to see that I'm going to ping from 10.160 to 10.161. I have an RDP session in a secure workload box over here. So let's test that out right now. So ping 10.161.98.233 is the east secure workload PC. There we go. Perfectly fine. You can see it's going over a different region because the latency is relatively high, so it's going to go over there. If I trace route that, 10.161.98.233, bam, all the way from the west to the east. Now, I'm not sure why this is saying west right here. It's actually the east. I'm not sure why it has resolved to west as a DNS, but it doesn't matter as a host name. So in any case, you can see it's going over the transit. Firewall is not in line of traffic. The other thing we want to test here is if it has internet connectivity. It shouldn't. If I ping google.com, yep, it's dead. If I ping 8.8.8.8, yep, it's dead. So no internet connectivity because I haven't enabled internet egress through the firewall. We're going to do this in two separate steps. So let's first inspect this traffic and force it to go through a firewall. To insert the firewalls in the path of traffic for that VPC, it's really not that hard. You just go to Transit Network, go to Transit FireNet, scroll down. Yes, we're going to select the FireNet in the west. That's the Fortinet one that we configured. And we're going to move this West Secure Host Gateway into the inspected list. Done. Now when we run that test again, we should see traffic being punted to the firewall on its way to the east. Let's try it out. Let's run that ping test again and see what's changed now that we have the firewalls in the line of traffic. There we go. We have an additional 4 milliseconds. You see that? It's 74. Before it was 70 milliseconds. Why do you think that is? Well, it has to go through firewalls, right? So it's hitting the gateway. The gateways are then hashing it and sending it to a firewall, and the firewall sending it onto its destination. So it has an additional hop there. If we do a trace route, we can see that additional hop. You're going to see here that it's going to hit the firewalls. There we go. 10.150 0.22, 10.150 0.4, and you're going to see it's going to stop a couple times because the firewall interface itself is not allowing ping, actually, is probably what the issue is. So let's let it get through that, and then it should hit the destination here momentarily. There you go. It went through the firewall. We can now validate that by looking at the firewall logs. So let's go back over here. Let's go to login report, forward traffic. There it is. There's all the traffic. Look at that. 10.160.35.46, which is my source, and I'm going to 10.161.98.233. So it's hitting my firewall. Look how beautiful that is. The Aviatrix gateways and the policy have inserted the firewalls into the line of traffic with a single click of just moving over that VPC to being inspected. We should also enable internet access for this guy. Enabling egress inspection is quite straightforward. Just under the Firewall Network Advanced section, you'll see here the two FireNets. So what we're going to do is we're going to enable on the west region the egress. So let's go over here. And we're going to do egress to firewall. Hell yeah. So what that's doing is advertising the default route to the host VPC. So the host VPC will send that to the gateway. The gateway will then send that to the transit gateway, which will then send it to the firewall. And so just propagated that default route end to end for you. All right, that was successful. Now, if I did my firewall configuration correctly, I should have internet access on that host now. So let's go back here and let's just try to ping 8.8.8.8. That's the internet. Wow, look at that. Beautiful. Beautiful, beautiful, beautiful. We didn't have to do anything but just move a slider to say, hey, yeah, I want to enable internet egress. And now it's being forced out the firewall. We're gonna get full inspection on that firewall, next generation firewall inspection. Let's also try to ping google.com. I think if I have my DNS set up, that should work as well. Yeah, look at that. Love it, love it. Even this, I've done this so many times, it still impresses me. It's just so cool. Let's go look at the firewall logs and make sure that it's hitting the firewall. Let's refresh these. Oh yeah, look at that. Hitting Google. Look at that destination. Fortinet's actually pretty cool. Fortinet does a really nice job with visualizations. Love it. All right, let's go do some checkpoint. Okay, next up, we're going to deploy the Cloud Guard firewalls in the East transit environment. Let's get to it. All right, guys, you've seen this before. To deploy the checkpoints, the same process. It's a repeatable process. No matter what firewall and no matter what cloud you're deploying this in, it's the exact same thing. That's the beauty of this. It's even cooler if you do this all via Terraform automation, which I'll show you in a different video. But for now, we're going to go to Firewall Network, Setup, scroll down to deploy the Firewall Network. That's step number 7A. And we're going to deploy the checkpoint. Okay, yep, select the primary gateway. We'll call this checkpoint 1. Okay, let's select, I think the one I'm going to use today is this guy right here with threat prevention. That should work. Let's try it out. Yeah, we'll leave the firewall version alone. We'll leave the firewall instance size alone. And we need to select our egress interface. So let's select 1A. We'll put the other guy in 1B. And that's it. Let's hit launch. See what happens. Okay, successful deployment on the first try. That's how easy it is. Look at this, checkpoint 1, you get the information, you even get the URL or the link to the management UI. Let's deploy the second guy. So under the same VPC of checkpoint, we're going to select the HA gateway this time because we're going to connect a different firewall to the HA gateway. So you have one in each availability zone. We'll call it checkpoint 2. And we're going to select the same one. Leave all that alone. Let's do 1B as the ingress egress this time and launch. All right, and she's done deploying as well. You can see the second one here, checkpoint 2 deployed. So what we're going to do now is configure the checkpoint firewalls the same way I did the Fortinets. Now, again, I'm going to spare you the time configuring it because you just got to go through the doc and it explains it step by step how to deploy it every screen after screen. So no point in doing that on video. So give me a moment, I'll be right back. Okay, so I got the checkpoint firewalls configured. It wasn't that hard, stood them up, did some basic interface configuration, some basic security policies, and enabled some NAT. Pretty straightforward. So what we're going to do now is jump onto the West Secure Workload PC and do a ping and a trace route to the East Secure Workload PC and see how it looks before we insert the next generation firewall into the path of traffic and then what it looks like afterwards. So what we're going to do is run a test from the secure workload in the East VPC going through the Checkpoint FireNet. However, I haven't enabled inspection yet. Going over the transit peering to the Fortinet FireNet in the west, and it will be inspected by the Fortinets, and then up into the west workload. So we're going to run a ping and a trace route and see how that looks. We'll also run a test to the internet and see how it looks before we enable inspection, and then we'll see what happens after we enable inspection. So here we are on the east workload. Let's run a ping to the west workload, see what it looks like. 79 milliseconds, all right, keep that in mind. Let's also run a trace route to that same IP and see what the path looks like. You should see only one stop in the response because that's the Fortinet environment. There it is, there's the block. So it's being inspected by the Fortinet environment. Perfect. Let's also see if we can get to the internet. Yeah, it looks like we can get to the internet. And you might be wondering, why can I get to the internet? I haven't enabled the local egress like we did in the west. Why can I hit the internet here? Well, it's because I'm actually learning the default from my west FireNet through the transit. And so I'm going from my east to the east transit, over the peering to the west, and then egressing to the internet over there. So what we're gonna have to do is, I don't want that to happen. I want to block that default route from coming across. So when I enable my own, I want to use my own default route that's local to my region. So let's go quickly block that default. To do that, go back over to the controller, and I have to go to my transit peering environment. And I have that default being propagated all over the place because I have some full mesh of routing happening here. So you go to here, we're gonna edit that guy. Don't worry about this right now. When you build out your own environment, you'll realize what to do. Okay, that's done. Now if I go back over here, I shouldn't be able to hit the internet anymore. Yeah, bam. Okay, great. So next step is actually to enable the checkpoint inspection for that workload VPC and see how it changes the behavior of the traffic path. So we go over to the transit FireNet section, scroll down, and then we select the east. We'll move over the east secure workload into the inspected spot. All right, it's done. Now let's run our ping to the same location. You can see here that our latency went up. Well, why? Well, it has to go through a set of firewalls now, so there's additional latency there. Let's run a trace route as well. You should now see 2 points in the trace route where you don't get a reply because it's going through 2 different environments, 2 different firewall environments that don't have ICMP enabled on their interfaces. There's the second one. So that's the Fortinet right there. Great. Now if we run a ping to the internet, it should still fail because I haven't enabled the internet egress through this FireNet yet. Yep, it's failing. So let's go enable the internet egress through this local firewall so I take my local internet out. Remember before, it was hitting like 80 milliseconds or something because it was going through the transit to the west. I hadn't blocked those default routes. So what I'm going to do is enable it, and you should see it should go down to like 3 or 2 milliseconds, something like that, because it'll be egressing locally. So we go to advanced, and we go under the east transit FireNet, and we're going to edit it, and we're going to enable egress through firewall. All right, it's done. So I should be able to go back over here and ping the internet now. Perfect. Look how beautiful that is. So fast, so seamless, so easy to propagate the default route appropriately to the right VPCs end to end. And you can now see I'm going out the internet locally through that firewall. So 2 milliseconds right there. Now let's just double check some of this and see if we see these flows on the checkpoint itself. If we scroll over here and I go to logs and monitor. Oh yeah, there we go. Look at all those flows. Okay, yeah, LAN to WAN, allow all, it's hitting all my host is doing a ton of traffic. Okay, great. All right, so a quick review on what we accomplished in this episode. We built these 2 transit networks, the Fortinet FireNet in the west and the Checkpoint FireNet in the east. We connected the west workload to the east workload through the firewall, so they're being inspected in both directions. And they're also taking their closest internet egress and leveraging the firewalls for inspection as they go out to the internet. Now, this would also be applicable if those workload VPCs wanted to reach the on-prem downstream. I didn't draw it in this diagram, but it would still flow through the firewall, and you can apply north-south inspection that way as well, not just east-west. I want to end every episode now with this slide. What did Aviatrix do for you? It's twofold. Aviatrix handled the entire build and life cycle of the network, as well as the entire operational and day two components of the network. So Aviatrix built out the VPCs, the IGWs, the subnets, the VGWs, the route tables, security groups, the EIPs, the interface assignments, everything. It does it all for you. Number two, it configured the gateways in HA. It configured the equal cost multipath routing and the IPsec tunnels, both the site to site and the transit to transit tunnels and configuration and routing. It also configured and propagated VPC and transit routes end to end. I'm talking about the CIDRs that are in every VPC, as well as the default route when we enable default routing for local internet egress for that region. It spun up the firewall instances and configured some basic configuration on them so we could get access to manage them. If you used Bootstrap, you could actually configure even more. So we're handling the lifecycle of those firewalls. We can insert more, we can remove them depending on the load required in the network. Then based on policy, we inserted those firewalls into the path of traffic so you could have inspection of that traffic. East-west, north-south, and egress to the internet. It also provided a Terraform interface for repeatability, so we could do this exact same thing via coding across multiple clouds without having to change our coding architecture. Lastly, it abstracted all the underlying complexity between these clouds, whether it was AWS, Azure, GCP, or multiple regions within the same cloud. It abstracted all the complexity underneath the covers. From an operational perspective, the FireNet gateways were hashing flows so that we could scale out our firewalls horizontally up to 70 gigabits per second, up to 20 firewalls across multiple availability zones. It helped us retain symmetry for routing so that the traffic would always go through the appropriate firewall. It allowed us to retain IP visibility. There was no need for a source NAT. We could leverage the underlay routing for massive throughput. No need for IPsec tunnels that would bog down our throughput. It also provided us a unified monitoring and management console, the Aviatrix UI, for firewall insertion. And lastly, it provided flow visibility with packet capture. So anywhere you have a gateway, you can leverage packet capture. And in a future video, we'll talk about Copilot and how we can extend that analytics into an additional platform that we have for even more visibility. I really hope you guys enjoyed this session. I'm looking forward to seeing you on the next one.